Okay, that looks like it's recording, so alrighty. Hello everyone and welcome. Thank you so much for coming out. This is a really exciting day because we're unveiling the culmination of 2 years of very hard work on the Tampa Devs Cloud, which is just a very exciting project because we're bringing a ton of state-of-the-art technology in the cloud to you, built completely by our team of volunteers from the bare metal up. They're going to tell you all about that journey, but it's for your benefit. It's so that you can learn, so that you can experiment, so that we can empower the community and educational institutions and researchers to have access to powerful hardware and state-of-the-art cloud technology at no cost to advance our mission of making Tampa Bay one of the most competitive centers for the technology industry on the East Coast, if not in the continental United States. So my name is Charlton Trezevant. I'm the co-founder of Tampa Devs. We've been around for, I think, about 5 years now. And the growth that we've achieved and everything we've been able to stitch together has just been wonderful. So our mission has always been to help bring together the very best of Tampa's developer community and different industry partners and so on, so that we can make Tampa the best place to start technology businesses, advance your career in technology, and just generally find opportunity in the technology space and kind of come together as a community. So with that said, a couple things about upcoming events. So this week there is the Florida Startup Summit. This is on October 17th. We've got a QR code here. It's up in Gainesville, so it's a little bit of a distance, but definitely a worthwhile thing to check out. We have another event this Thursday that will be about patterns for building AI-powered applications. That's really exciting. And then the next week, we have a memorial event for Vincent Tang, my very good friend and the co-founder of Tampa Devs, who tragically passed away within the last month or two. And if you want to share stories of Vincent and kind of honor his memory, we more than invite you to come out and check that out. But that's what's on the docket for our upcoming events.
One more event.
Yeah, go ahead.
The day immediately after Vincent's
which is on the 23rd.
So October 24th, on the Friday, we'll be having all the tech groups as well as a bunch of the cybersecurity groups at the largest art space in Tampa within Ybor, doing a Halloween party. Mm-hmm. And we are in the middle of working on the logistics as far as like sponsorships and this and that. But be on the lookout for that as well.
Yeah, all of this is on our meetup page. You can find that on our website, tampadevs.com. And yeah, the full schedule of events is there for your review. But we'd love to see you at all of those, and we appreciate you coming here today. I'm going to go ahead and turn it over to our cloud architect extraordinaire, Justin Heron, to tell you everything that you need to know about why we built a cloud and how it works. Give Justin a big hand.
All right, so yeah, this has been a journey, to say the least. And the number one question I've always asked is like, why did a meetup group build a cloud? And the number one thing is because it's like, anyone can start a meetup group. We wanted to basically just be something more than a meetup group. So a centralized place where everyone can kind of come in and learn from each other. That's one thing I've gotten from all the Bay hacks, like the hackathons, and all the other meetups that we have where we actually exchange technology together. When I saw Tampa Devs really hum and synchronize is when we were all slapping keyboards and we were all writing code together. We wanted to mainly provide that theater for collaboration where everybody could experiment on code without being gatekeeped by a bureaucrat somewhere. Like, no, you can't do that because that's going to cost money. So that's why we did it. So again, big round of applause for project sponsors because without them, this would have not happened. So total impact of the Tampa Devs Cloud. The number one thing it allows us to do is gives us the ability to host developer projects, your blogs, your resumes, your things that you want to showcase to potential employers. Yes, you could do it on GCP. Yes, you could do it on AWS. Yes, you could do it on name your cloud provider here, but you're going to accrue a cost for that. If you wanted to say showcase a meetup somewhere, like, hey, I want to show about this really cool cat blog that I made. You can't do that as a developer without accruing a cost. And that's what this whole project was to aim, was to take you, the developers, and you, the operators, and the people that make things, be able to come and showcase that skill set without accruing a cost to do so. But total impact, let's say if Tampa Devs had to pay for all this, we're talking $1,500 to $2,000 a month in rack costs, initial hardware between $50,000 to $70,000. Thank you, XByte. And then consulting and licensing fees anywhere from $300,000 to $500,000. So all in total, if there's a whole team involved in this, maybe about $1.2 million on the average side.
We did it for free.
And we did play for free. But this is the Tampa Devs Cloud. This is the data center. This is stuff that many, many nights I was in there building. The two big girls right there, those are the thank you very much XByte. And then the very bottom servers we have there, those are our GPU nodes to run AI ML stuff. We're very limited on that, so there's a waiting list if you guys want to do that stuff. But
Bump up if you give us GPUs though.
yes. But I'll show you what the console looks like. That's the wrong one. Let me log out of here. Hold on. This is what you as a developer would see. That's the developer perspective. So I don't want to spend too much time on here because my number 2, Brian, is going to walk you through the whole kit and caboodle here in a second. But this would, let me go back over here. Here we are. All right, cool. Okay. So what does it provide? Managed Kubernetes clusters. The core technology that drives the entire Tampa Devs Cloud is Kubernetes. We use a management platform called OKD, or Open Kubernetes Distribution, but that just allows us the ability to manage all of the Kubernetes clusters that our members are going to be deploying. We also have 2 game servers that are running right now. We have a Factorio server and a Minecraft server. This base right here was the result of putting a Factorio server online for 1 day. That was the entire Tampa Devs community. Just unloaded the creativity in that environment. So that's the power right there, where we were able to provide it to the community, had all these people join, and then they just made that. And that's what we're here to foster. We also have hosted virtual desktops coming in down the line. That's a really complex architecture that we're still currently working on. A lot of challenges with that, but it's in the pipeline to come through.
Think of it like your factory floor.
Yeah. The last thing I just want to mention, as the principal architect here for Tampa Devs, Tampa Devs Cloud, my promise to you guys, I don't want your code. Your code is yours. Any code that you guys make, any code that you guys develop in the Tampa Devs Cloud is the property of you. We just hope that this will be useful. And if you guys find things that can make it better, I hope that you guys ping in hey, this could be way better this way. Okay, we'll entertain that. Let's explore that. But I'm not here to say, you developed your code on Tampa Devs Cloud, we deserve 10% of that. No, that's not what we're here for. So, now before we start, I just want to demystify some terms and bring everybody up to the same kind of understanding. A container, more so, is a running instance of what is known as a container image, right? That we build from a Docker file or a container file. A Docker file or container file is it's a plain text file with a set of instructions on how to build this image. And then what we use is a container image, and we use a container runtime, to Docker or Podman to run that container image and then store it in a registry. And then we'll use those runtimes to pull and consume that down into the cluster. Some Kubernetes basics. We have nodes, we have pods, and we have containers. Containers sit in pods, pods sit in nodes, and then nodes are isolated by what's known as a namespace. Good? All right. I'm moving kind of fast here, but last part is how is all the security handled? Well, Kubernetes in itself has some basic built-in security features to it. We have what's called RBACs, or role-based access controls, and SEC, security context constraints. RBACs basically limit the user's individual ability to do things on the cluster based upon its role, and the security context constraints prevent things from happening at the pod layer. So the security context layer polices the pod, the RBAC polices the user. And then lastly, on the nodes themselves, they run an immutable operating system called CoreOS. So the core system files are read-only, while as the rest of the system is we can able to run pods and workloads on there without compromising the node itself. Now, I'll go ahead and turn this over to Brian. He'll walk you through the whole deployment process and go from there. Okay.
No.
Never mind.
Okay, so for this part, community developers trying to get people to on the cloud. So this is targeted. It's an intro to Kubernetes. So everything you see here, pretty basic. We'll save some of the deeper ones for later. But the goal here is to hope that you see why there's value to the cloud, maybe ideas to get started or why you want to bring your project, or if you're just curious and like to mess with new technology, this is a perfect way to do it. So why should you be excited? As Justin mentioned, it's free compute storage. If you've ever dabbled in AWS, Google, things are expensive. You always have the fear if you run something overnight and you wake up to a very expensive bill sometimes. Here you can run your applications, run your deployments, consume resources, and not have to worry about situations like that. The other part too is we're running Kubernetes. It exists in enterprise platforms, so you're getting hands-on use of stuff that major tech companies are using, big and small. They have the ability to mess with the technology without having to pay is another value. If you don't have any applications you want to run or you're building, but just want to learn how the things work, whether from an infrastructure side or an application side, you can perfectly join in and start to explore. And then as part of the next few slides, if you're familiar with Docker, virtual machines, we're going to go beyond Docker runs. So if you have built containers, built applications, we're just going to show some examples of how you can take that knowledge and what you've done before and move it to the cloud and start to mess with the new technology. So as you said, this one, introduction, perfect for students, hobby projects, maybe startup MVPs if you're messing around with ideas, and people that just want to learn. Just a key thing, so when you start thinking in Kubernetes, we think of this, you'll see it a lot if you do any reading, pets versus cattle. When you're on your laptop at home, you're dealing with Docker containers, you have a VM running, something goes wrong, you log in and fix it. These are all very unique servers, they're very unique instances that you always expect to be there. In Kubernetes, those are called stateful sets. We'll kind of show more in a few later slides of the example. The other part is the cattle. These are your pods, these are your containers that are very disposable. They're built from a template, they're read-only. When they get deployed, they perform a purpose. The Kubernetes layer watches them. If something goes wrong, if you start seeing failures, the system itself will remove it from the cluster, add a new one, and allow you to keep your applications running. So as you start to build, you can start to scale up your applications. You can start to see that how you can load balance across multiple instances, and it really helps you start to build instead of just single monolithic applications, microservices, and really expanding your skill set there. And it's also perfect for web servers, APIs, and stateless apps. So I know this might be an eye chart or eye test for the people in the back, but and if you have any questions, if you go through, feel free to raise your hand. I want to be able to explain things as it happens. So we're not doing live demos. Everything will just be on the slides. But to get started with a basic app. So in this example, we're just going to deploy a container. So if you go on Docker Hub or GitHub repository, you can find a pre-built container. You can launch it. So you log into the cluster. You have your new project you create. That's your own personal workspace. You can build the new application. So it's a placeholder for your resources. In this case, we'll just pull right from Docker. So if you go to Docker Hub, there's an OpenShift/Hello OpenShift that very creatively just displays a web page. You expose it to the internet, and then you can get a URL. So that gets generated by the cluster automatically. So if you're familiar with Amazon or any other cloud providers where you get your dynamic URL, this is just an example. Here you go. You're already running. You've deployed your first app. So, and if you want to load balance it, you can scale that to multiple different pods, and Kubernetes handles all the traffic routing. So, yay. Okay, so now, did I miss this one? Oh no. Okay. So in this one too, so now that was kind of the command line. If you were just starting to get used to it, as Justin showed, there's a web interface. So when you log in using the same credentials, this just kind of shows how you would get started there. So you would deploy, you'd go to your container image, you would enter at the very top here is where you would enter the name of it, whether from Docker or any other repository. And then you build your application name, and it really populates everything for you, and it automatically will create a route. So once you hit create, it pulls the image, starts spinning up the services, and here's your URL, all visual, and you're ready to go. And you can see here, you can see your pods of the actual running container, the services of how it gets traffic routed to it, and then the route for the outside. So another visual display if you want to kind of dabble from that side. And I'll use like the visual model going forward. Any questions over? Good.
So you guys basically built Vercel?
What's that?
Vercel?
It does more than Next.js. So, basically, I mean, all the orchestration there. You can build apps, you can deploy them, you can pull them down. If you stick around later, like
I still don't wake up in the morning with a huge bill.
Exactly. That's the big one. No big bills.
Wonderful.
Yes. So as you can see, so this is a stateless pod. You can't. It starts up. It does the same information. We'll always show hello from hello world, and if it runs until it dies, and if it dies, it's replaced. So that's cool, but we need apps that most real apps do things that remember, have more interactivity. So the next example is we'll kind of take more of the Docker run stuff, so volumes and storage and environmental variables, into the next phase to actually deploy like a real application that someone would use. So for this one, I just went on. Flowise is if you ever done like AI orchestration at N8N alternative, it's an open source version that they have. And it's a web interface, and it writes all its data to an SQLite database, so it can keep and persist all your information. So we'll use this as, I'm a developer, I want to mess with it, let's deploy it to the cloud for free instead of having to pay, or run it locally so it's always on. So we kind of follow the same path. We go in the top, for the image name, we would use the Docker Hub. We create our application, and then everything else gets populated. Target port is where the traffic would go. And since it's a Docker image, it will get pulled. You will see the services in there, so everything is routed as needed. And it really just simplifies the setup. Now, the only problem with this is we said containers are read-only, so this one is going to throw errors. You see like the big red circle, and you can see in the UI now your pod has a crash, so it's unable to start. So if we would go to click logs, you can start to see, all through the web interface, what's going on. So this is your logging that you're going to be used to in Docker. And then if you start reading through, basically it's saying it can't write. So we need to add, we would need to add storage to that. So write all the things. I might be really dating myself, I realized, on that meme. I think it's I realized how old it was on the drive here.
That was amazing.
So that one I was like, so what we do, in Kubernetes is persistent volume claims are how your resources would say, I need to store. So just like you would create a volume in Docker, your persistent volume claim here is what you would create. So you go into the web interface, same spot when you do your deployment, and you would see persistent volume claim section. You create new, you add your size, and then the name of you want a reference to, and then hit create. And then that will give you your storage that you can attach to the container. So now back to our the main status page of our deployment. Since deployments are what's managing the our application, we would go to actions and then just add storage. And then we would just select our PVC that we created before. Mount path is typically how you would use. So if you're doing your Docker V, where you would mount it in the container. So every application might be different. You would mount it. And then lastly, environmental variables. So Kubernetes, when really creative, they still call it environmental variables, so nothing new to learn there. You can get past them from the deployment. So in this example, we're just adding them through here. There's other ways to add them, to make, if you start dealing with very large env files, you can use config sets and everything else. But for the sake of this example, we will just add them. These are all from the Flowise documentation. You just need to map the port, the home directory, database path, everything that you would write your data, and then hit save. And since Kubernetes and it's the one's watching everything you change, it sees the change and it automatically pushes it to the pod, into the deployment. So now, happy blue circles. So our pod is running. You can see that it's got the blue circle, which means everything's running. You can see our status now is showing running. And now we still have our location if you wanted to log into it. And that one is still running today, so it is. And then we can show later too if we delete the pod because that persistent storage is there, it'll start fresh, but all of our login information is there, so it's still just using the same storage. So the other one comes up, what about databases? So if you're doing any workloads and want to store data on our cloud, you can run stateful sets is what you want. You need a resource now that we're talking with the pet side of the pets and cattle, is you need a resource that's always there. You need to be able to how to access it. And you want to make sure it's the only one accessing the storage. We don't want data getting corrupted if something were to get removed, as we said, if pod gets cycled through. So for here, same concepts. We need a claim to store the data. The stateful set, instead of the deployment this time, is going to be controlling everything we set up. And then the service kind of designs the internal address that our apps can use to access stuff inside the cluster. Again, create the PVC, similar as before. Now we go into, instead of a deployment, we have to select stateful set from our inventory in the bottom left. And then this one, it does make you use text. Unfortunately, there's no UI for this, which always annoys me. But it does, so here, it does stage a lot. So this does kind of maybe look scary if you're not familiar with it, but when you launch a stateful set, it does generate you a template you're not expected to type from scratch. I'll show you in the future too, if you really want help, LLMs are great at writing YAML. So it's if you help structure to help move things along. But you can see here, we basically cover everything we're doing in the UI. You have your application name, you have your volumes, where your PVC claim and where you're mounting it. You have your, in this case, MariaDB, the image we're using, so we're just using a hosted one. And then we have an environmental variable. In this case, it's a root password. So I will preface, don't run this in production. As you can see, your root password for your database is right there. This is just to document and show how some of these files are set up. So there's different ways to store secrets, but we just wanted to show if you need to set something up, you can. And then lastly, your port. So this is where you would route traffic, 3306, just the standard port. And then, so now our service can run, but we need to be able to, our application can run, but we need to access traffic, or we need to tell Kubernetes how to route traffic to it. So the last piece is a service. Another one, if you do the web interface, you have to use the text version. All you have to do is change the port and protocol. Everything else is generated for you as part of your project. So this is another one, very simple. It looks scarier than it is if you're not familiar with it. And then, so our application's running, and now how do we connect? So if we're working inside our cluster, if we have a web interface or anything else that needs to reference it, our service URL is available inside the cluster. So if you had a WordPress deployment that was running, that's the URL that you could push and allow it to connect to the backend. As well as if you're using services inside, just like Docker, if you've done it, you can reference it by the service name. So MariaDB will connect as well inside the cluster. And then here's just an example. If we want to connect, so if we were going to run a deployment, so now we have our stateful set that's always on, it's our database. Now it's our cattle in the field, all of our running instances of our web app that we wrote. You would typically see how you pass the database host. Here you can just use MariaDB. You don't have to worry about the IP address and everything else because that service is always there. So it allows you to not have to manage or change IP addresses every time something were to go up and down. And again, database password, just an example. Don't do that.
Oh, I'm doing.
And then here, just an example, you can see, we have our stateful set, which is our database, and then our deployment, which is our WordPress pods, and then this can scale up and down. So as if your blog went viral, the cluster can actually add more pods to serve the web page and allow you to connect to the database as well. So it's just kind of what a normal modern app would look like. Okay, any questions? Good? Okay, just a couple tools. So when you're building, if you're not into like all the web apps and everything else, there's some cool little tools you can use from developing. So we mentioned building a database. You don't have to connect from a web browser. you can port forward into the cluster. So if you deploy your own database, you just want to store a bunch of tables, maybe you're trading crypto or doing whatever and want to store stock charts, you can just port forward from your laptop using that simple command, and you can connect locally from there into your database. So it gives you the ability, without having to build a whole web interface to it, how you can just manage data, run queries, do whatever you need, and have a data store that's always running. And then here's just an example. You can see it's connected, dbVers is connected to the local database, localhost 3306, but it's running on the cloud, so you have now an always-on backed up cluster, or a database server that you can run. And there's a couple others. So if you're running a pod and you want to get a terminal session in it, OCRSH gives you the remote shell. If you want to copy files to and from it, your same thing from the command line, just help you kind of speed the development along, and just some little tidbits. Okay, we reviewed, stateless, everything else. And then lastly, helpful resources. So we could share these. One of them is a blog post from Red Hat Learning. It talks about all the different commands and how you can run, creating new apps that are commented out. It's just a plain text post, but it has a great list of OpenShift commands you can use on there. And it's just everything. It's just really good wealth of information from very simple post. And then lastly, as I mentioned, Google AI Studio. This is a prompt I use. If you're really trying to troubleshoot anything, Google, like any LLM, will just dump the entire information to you and won't really help you learn anything. If you use this prompt, as you start to issue, so if you copy and paste an example, if you run a pod and have an error, if you paste it in, it actually starts going through and it will break down what's happening. So it'll tell you what you're seeing and it'll tell you how to investigate. And it's been very good at walking through step by step, capture logs, upload them, what it means, and how to troubleshoot. So if you're looks like to tinker around and figure out what's going on inside your cluster, it's a great resource to have, almost like a senior architect if Justin's not answering his phone. You?
So, do we take over?
Yeah.
Okay. So how do you guys get started? I'm sure is a question. Oh, you wanna? Okay, cool. Yeah. Did a great job, buddy.
Thanks.
All right. So how do you guys get started? Scan me. This is a little form. It's going to ask you for the GitHub handle. Put it in mine. It's dsyncit. So DESYNCIT. That's my handle. I'll put it over here. Just put my name there as the person who referred you. So DESYNCIT. That generates a ticket, or that generates an issue inside of GitHub, so that way I can add you guys to the cloud infrastructure. Add you guys to let you log in. Everybody got it? Cool. All right. So, now the fun part, and this is where I get to have fun at. This is version 1 of the Tampa Devs Cloud. This is what we use at Bayhacks. These are two R720s. This is another R720, and this is an R520. The performance was so bad. Once we got 2 users on the cloud, it was just blew up. So Xbyte came in and like, here's some professional hardware, and saved our lives. So this is actually Vincent Tang. The first time before I met Charlton here, I met him, and Vincent actually came to the data center, and I gave him a whole tour. And then that was where Joseph and Charlton, we came in and we were installing version 1 of the Tampa Devs Cloud.
And he will be back in January. We're so excited.
So, how do containers work in their ultimate magic, right? So just like a ISO with a virtual machine or a VPC a virtual machine is a running instance of an ISO or VDK or what have you. A container is a running instance of a container image, more or less, that leverages existing Linux technologies. So in Linux, we have something that's called a namespace. So whenever you boot up a Linux system, you're in namespace 0, right? So what we can basically do is that containers leverage this concept for kernel namespace to isolate workloads. So we create another namespace, and in that namespace, it has its own file and directories, resource allocations. Now, how do we allocate resources to that namespace? We use a concept called cgroups. And then, how do we make sure that these namespaces are accessing files that they're allowed to access? We use a concept called SELinux. which places labels on each one of these files saying, hey, you're not allowed to touch this file. And then it causes an error. And then lastly, okay, great. Well, I'm sure the security engineers are like, well, okay, fine. I can just manipulate system calls then. No, you can't. Secure computing mode that polices the system calls. So that whole stack in the Linux kernel makes containerization possible, where we can isolate workloads to specific named spaces in the kernel and allocate time on those resources based upon certain priorities. So how is all of this deployed? This deployed was called with Ansible automation, my favorite tool that is the biggest troll in the world. I break the stages up into the 3 different stages. The virtualization nodes we're about to get here in a second. We deploy the base operating system out. We deploy the distributed storage out and distributed in the container registry to pull the container images down from Docker Hub and Quay.io, which are 2 registries that I use to pull stuff down. And then we do a switch on the last stage here, where we actually use an operator called Argo CD, which takes the rest of it and pulls from another repository and then bootstraps the rest of the cluster out. And then Argo CD takes off from there. So it's kind of a multi-stage approach here, which was so hard to figure out, but 15,000 lines of code later, it works. This is the basic model. So these are the virtual nodes. So the virtual nodes and the physical nodes, they use a distributed storage system called Ceph. If you've never used this before, I highly suggest it. It is a huge troll, but it is beautiful the way that it works. Provides all the storage systems that we need: block, object, and file storage, all in one storage array, all in one storage system. You can run on any commodity hardware. You can run it on Raspberry Pis. You can run it on all the way up into high compute nodes. And then these are the physical nodes that run the GPUs. The GPU nodes sit in these 2 chassis right underneath the big ones. They also consume the Ceph storage via what's called the Rook Ceph operator, that then pulls in the GPU node. We actually compile the GPU modules in line, which was incredibly difficult to do. And I will piggyback off of Linus Torvalds here and say, you NVIDIA, 100%. CoreOS, basically, that's what's saying. That's the immutable operating system that we use that leverages a container runtime called Cryo and Containerd, and then pulls in Kubernetes, and then schedules the workloads on those nodes based upon labeling that you put in the actual project spaces. That's all, folks. So, I'm sure there are loads of questions here. No? Go ahead.
Can you do like a very real simple example of the user interface? I know you went through most of the steps here, but just a quick summary of it.
What do you mean, like show the actual user interface? Yeah, sure.
Or maybe as a, do you have a GitHub account?
I do.
Maybe onboard.
Yeah, we could do that. Let's do it. Let me close out of this here. Do you want to cover the extra stuff first?
Do you want to run through it? We can. It's like some of the game server stuff.
Yeah.
Oh, it's like national left in there.
We'll pause that one real quick, if that's okay. So we did the Kubernetes lingo.
We already did that one.
Yeah, we already did that. Here's this is the Factorio server we had built out right here. This is the actual game interface. Do you want to describe this since you built this?
Oh yeah, so it's like, so as the Tampa Devs Gaming, so we had a page that monitored. So one of the things obviously you do at Kubernetes is you can have cron jobs that run. So we had a simple script that logged in, see who was playing every minute, and then route it to a database. Just the simple deployments at the bottom, but it's just something you could do that fed it to the web interface. So we were tracking how many players, who was on there the longest, and then the evolution of the game if you ever played.
I have the most hours. That's my name right there.
It's an old snapshot.
Come on, man.
And then as some of the orchestration that goes on, I think you go next slide. So right now we have, so this is like about fully orchestrated. So right now Factorio updates, they'll have a new version out. It's in our GitHub for the repository. You can open a pull request that edits the version of the Docker file. GitHub Action goes and builds a Docker file, submits it to the registry, and then Kubernetes watches the source image, and when it sees the update, it'll pull it down and swap it out, so we can stay on top of Factorio updates, which I swear come like every week now.
Yes.
But
This game constantly updates, and it drives me crazy.
so I think this is the one I did for my phone. Yes.
But this would be an example of like how to manage a full application lifecycle automatically using this infrastructure, right?
Yeah, yeah. So you have like a repo of like if you have a Docker file or like your application you're building, and then you can use your GitHub Actions to build it and host it. And so instead of manually building a Docker file and uploading it to Docker Hub every time, you can just update your code on GitHub using GitHub Actions. And they can build it for you and host it. So the cloud and Kubernetes can just pull it down for you. Saves a step, and if you're on slow internet, yes.
And this is open source. For example, if folks wanted to check it out and maybe use it for their own apps that they run the cluster.
Yeah. Yep. And then here's like, yeah, go back one.
Sorry.
So then it's on, so GitHub Action, so when it sees the commit, it has a tag. So there's a PR for the version bump. It goes through, sets up the job, checks out the repository, runs a Docker build, and then uploads it to the repository you can see. And that's basically just the GitHub Action from the merge.
It's the power of automation.
And then on inside GitHub itself, this is GitHub CR. This is all that. Oh, that one.
Right.
That one. Yep. You can see because we watched the latest tag, whatever the latest version is, it'll pull down. And then inside Kubernetes, we have it always pull the latest version. So just killing the pod. We actually have an update waiting, I think.
Yes.
I think we're a version behind, so we could kill it.
We're one version behind right now. It's driving me crazy because I want to get back on it, but I've been waiting for this to go through.
So like we can open a PR, I think, today if we have time. If we have time.
Yeah.
But just some things you could do, and then other things like cron jobs. So almost any workload you have, you can run on a Kubernetes cloud, save money, move away from AWS.
There's another way. So like my whole blog that I run, I use that same model where I basically have a Hugo web server. That Hugo web server basically, anytime I update something to Hugo, I push that Hugo up to let's say like check out a branch, put that branch in, make all my changes, merge in the main. The main triggers a mirror to GitHub from GitLab because yes, I'm that guy. Triggers a mirror to GitHub, and then basically from the build config gets a push from a webhook from GitHub, which then triggers the build to kick off because a new change just happened. And then once the build finishes, it pushes the new image to production. All without me touching anything in the infrastructure. And then here's the repos. So like main user forum, this is where people go to like discuss things they don't want to use Slack. If you want to submit apps to be hosted by Tampa Devs, like on tampa.dev domain, if you have your own domain, we can walk through that whole process too. I can host any domain, whichever you want. But if you want to just host it like John's app.ontampa.dev, we can do that. And then you'd submit a PR to be hosted in there, and then we'd pull it into the cluster, and then we'd automate the whole process out. So that way, all you as developers would have to do is just maintain the code base, and we would automate the entire infrastructure side. And I'm about to show you guys here.
And we are working on a set of reusable runbooks and playbooks for folks to give you an easy starting point to hop into this stuff, I believe.
So, anyway, I think we got time. Yeah, how much time we got?
So, still got another, well, we should be cleaning up in about 30 minutes, but I think,
Yes.
I forgot your name, I'm so sorry. Carlos would like to be onboarded.
Yes, yes. So, let's do this here. So we'll go to
I don't want to be held up.
No, it's cool. We got time, dude. So let me go here. We'll go to GitHub. This is all math stuff. So how I basically onboard a user, I would go to the forum side here. We got 2? All right, that's cool. Right on. Did you fill out the form?
I did.
Let's see.
Okay.
Or maybe it.
And I see Ryan also signed up. Where's Ryan? Oh, there we go. Nice.
It may have, to be honest with you guys, it was a JavaScript I wrote. I'm not a web developer. I'm a data center guy. Like I just janked that together, script kidded it, so.
It was functional,
It worked twice. So let's see here. Where's Ryan? Okay, let's add. So let me add your username. All right, so I gotta go back over here real quick. This might take a minute here. So let's do GitHub. We open up the second repo. Just to keep things away from Sandbox, from like the infrastructure code and the team, like keep things somewhat secure in a process here. The forum repo is how we the front facing side. I just gotta go back. GitHub's interface is killing me sometimes. All right, so we go to Teams, and then we go to TDevs Cloud. Oh, that's also one of my colleagues in Denmark. We have international help here. His name's Hagen. He works with me. He's a really good guy. All right, I've invited you. You have to go and accept it.
We use GitHub for all our IAM on the cloud.
Carlos, did you already?
Yes.
Okay.
So,
Which is your?
Let's maybe refresh that issues
Yeah,
list.
it's not there.
yeah, I'm trying to, wait. We got a Thomas Powell over here. Did you not do it?
Eh?
Did
Well,
you
here.
fill the
Yeah, I
Google-
just did it again.
The Google
Okay.
form?
Well, let's just do this here.
Hey, we could onboard any other volunteer that is already there.
Yeah, hold on. I actually need to. That just pulled him into the wrong team. Sorry. Let's go to Cloud Tenants here. I'll just do this here. MCM. Ryan, what was your user again? Right there? Yeah. Okay, what was yours? What's your handle?
Herding AI.
Herding.
AI.
Interesting.
That one?
Yes, sir.
All right.
Nice handle.
Thank you.
All right, cool. Charles, what, really? You're an org member, bro. Like,
I wanted to be included.
So for the people who fill out the form, just keep in mind that you have to do it without the ampersand.
Oh,
Without the-
that's
the
why.
A,
That's
because that's confusing and that's how I made it to.
thank you for that.
Yeah.
Justin, can you check if Bill, did you go Bill or William? Or what's your GitHub? Okay, what's the GitHub handle?
Let me just do this here. Let me just invite.
First one.
First one? Gotcha. This did not go as smooth as I planned it out to be. Anyone else? Thomas, what's your handle?
Well, I can use mine. Strings and 88 keys.
What is it?
Strings.
Springs?
Strings.
Strings.
Guitar
Strings,
Okay.
the letter N, 8 keys. There it is. Yeah, that's it.
You have a YouTube channel too, don't you?
Yeah.
Where you're playing like keyboards, right? Like
Yeah.
you're like pianos.
Also, do you have W Moyer 01?
So
Dot.
W.
MOYER. Sorry. Yes, right? 01.
Yeah.
Yeah.
Right there?
Good.
Yeah.
Okay, so there's that one, and then there's also the one with dash NET, EXT.
Yeah, that one's already in.
Okay, that's good. That's good.
All right, cool.
Anyone else? All right.
Right 8.
Say again?
CWRIGHT 8.
Right. 8. First one?
Yep.
Okay. You just got to go in and accept the invite. Next.
Yeah.
Okay.
Buffalo,
Spell it.
Buffalo, 1981.
B.
BUFALO.
Thank you.
No, it's A1.
BUFA.
No. BFALO.
Buffalo Bill.
1981.
Oh, 1981.
Yes.
You? Perfect.
Okay, Darshan, you want it?
Yep. Sonitron. SONITRON.
One more time.
SONITRON.
TRON. Which one?
The first one.
Gotcha.
All right, anybody else would like to be onboarded? Okay. Go. Yeah, go.
Just come up here, right?
Okay, it might be faster if you actually go and type it in. Otherwise, yeah, otherwise.
Yeah, if you want access, just come up here. Just
Yeah,
yeah.
type it in.
Access for everyone.
Yeah, type it in.
Yeah, we're getting a buttload of users now.
Absolutely. We're gonna put those onboarding run books to the test.
Okay, it's a 15-inch screen, so don't judge me. Okay. And then invite. Right here. It's not a MacBook, okay?
Not just Linux.
Just hit add member. Add member.
Okay, anybody?
Next person. Just add member. Right here. Right here.
Oh, sorry.
And Nate, you're already on there, yeah?
And I did it wrong. That's fine.
You're not a GitHub member, dude.
My hands are slippery nowadays. There we go.
Okay, come on down. Just hit add. I'm gonna need y'all's help, by the way, for managing all this. You guys can't sit passive
I'm
anymore.
on the hook. I'm on the hook. Yes.
Yeah, we can start a podcast using the cloud.
Yeah,
Cloud.
he runs one. We can go over on his.
Yeah. Yeah, we had you one at once. We'll do it more.
So, and there's one thing when we all get done adding, I want to show you guys as helpful resources. So, hit add. Cool.
Oh, you mean the company itself?
Yeah, they literally open pull requests.
Yeah.
And like edit text files and like add the like the username and the team name as soon as you push.
And then they get on the test track.
That's right. That's right.
It was literally a JavaScript app that I put in Google Forms. I had no idea what I was doing.
You mean it worked?
Kinda.
Well, no, it was the name.
Yeah.
Oh.
Add.
Now we know.
Last but not least.
I'll try to put a little light. Is it home? No, it's in Washington.
Oh, nice.
Yeah.
So, and then just hit add to Cloud Tenants. Perfect. Anyone else? Going once?
RUSUSF.
RUSUSF?
Yes.
USF. You?
Yes. Thank you.
So how do they actually log in, Justin?
I'm about to go through here in a second. Anyone else? Only once. Twice. All right, we're good. Okay, so basically what that just did is that invited all of you guys who just joined into the actual Tampa Devs GitHub, right, organization. So now when you log in, when you actually go to the GitHub, what you're going to look for is the Cloud Tenants, or sorry, the Cloud Development Forum. When I go back to it here, so you go into repositories. Cloud Development Forum is the one you want to go to. That has our amazing wiki. I wrote myself. Right there, first time caller, start here, wiki. Which will take you to how to get started. So I called it, the cluster, by the way, is named the Gaspar cluster. Because, Jose Gaspar, Tampa, get it? All right. I know my jokes aren't that funny, but I'm trying, all right?
That was funny.
I thought it was fun.
So right here is where you want to click. It's called the Open Console, right? Where you click it. Easy way to remember the Open Console: cloud.ontampa.dev. That's the whole URL. And then when you log in, do not click on the cluster login because that's disabled. It's just there for whatever. Google is restricted to Tampa Devs members on, like Tampa Dev domain name. So what you guys would log in is with GitHub. This is not what you'll see here, but I'm gonna log out of there. Because I'm a cluster admin, so it's different. But you as a user would log in through GitHub and you would see something similar to this. If you don't have anything rocking and rolling, but you have that. That's typically what you should see, right? Now, I'm sure y'all are like, okay, cool, how do we get started? Like, how do we even do things? Okay, there's this really cool feature that we got set up called Quick Starts, which brings you through a full course, right? So, basically what we'll do is that this will teach you how to create a node. We're not writing a node application here, we're just pulling in a node application, right? So what you basically do is you're creating a node application. We would view the build status, we'd view the associated code, we view the pod status, and run the node application. The whole start to finish deployment process, right? So here, we go to create a node application, deploy, we click the perspective switcher, it even highlights it for you. All right, at the top, we click developer, the navigation menu, we're gonna click add, which is right there. Then you would say, in the project drop-down menu, create a project, so we go here. We already have one up, rock and rolling, but you would click create a project, which would then you fill out this form. After you've done that, we create it. Now we click on the add, which we're already there, but this is the add right here. Now, let's say you guys have Docker-ready files or container-ready projects ready to go. Right? Like you have like a container file or a Docker file somewhere in a GitHub repository that you want to deploy it. If you try to run this as a privileged as a root level container, it will error out. All the containers, they have to run as non-root users or non-privileged containers. So if you try to run a root level container, it will not let you run it. The security side I already know is going to be the biggest pain in the rear for this whole project, but we're standing by to help. So, but anyway, so what we would click on is, let's say we're going to import from Git. So this is a little Node.js REST app that we'd come down here, and this is just the repository, which has a Docker file ready to go. And inside, not that one either. Nope, still wrong. There we go. So basically what we do is that we take this guy, or this URL right here, and then we just slap it in there. Okay? It scans the repo automatically, finds the Docker file, loads it into place, and it's saying, hey, let's go. You guys ready? Yeah, we're ready to go. But let's say, you want to, no, I don't trust you. I've got PTSD here. No, thank you. Let me make sure everything's good. Yep, okay. I want to do the deployment. The ports are right, create a route, awesome, yay. All right, everything looks good. All right, click create. Now it's created. Now this is the build that he was talking, that Brian was talking about earlier, right? So now what we do is that we pull it down. We actually pull down the code from GitHub, where we actually pull it down and we're building the process right here. So build one is running. Where you actually go into the logs and you see the container is, let me just bring that out and just, you see the container is building right here. You can watch the whole build process. 90% of the time this will fail either because the code is wrong or because you're trying to do root level things. But if you honor those two things, it will run through fine. So before you blame the infrastructure, look at the code first.
How long does it build?
It depends. So if you're just springing up like a Python module HTTP server to just say, hey, hello world, like that. Full blown NPM build, it can take 10 minutes. It can take, but it pulls the code down, runs through the whole Docker file, pulls all, like everything in there, copies the files over, everything you need to run the Node.js app. Is that what it's called?
Yeah.
So now we're running right here, npm install. And then pulls it through, prints out this warning, like this is not secure, you shouldn't do this. It's like, that's not supported anymore.
Do it now.
I didn't do that.
Do it later.
It's probably grabbing 500 megabytes of string padding libraries.
Yes, and then it's pulling it all down. Look, hey look, it's not supported anymore. I'm like, I'm just the operator, man. I just put this stuff together. And then it builds, and then you can see it's here, it's running, and then you can actually see like, hey, what are my build metrics look like? What's my memory usage look like? What's my file system utilization look like? Why am I using 100 megabytes worth of memory to build this? Let's see if I can cut that down to 25 or what have you. So you get real world, you get build metrics while you're building. And then it builds, and it builds. I think we're about done, actually. Almost
Just grabbed all the dependencies. So.
172 packages.
Oh, that's enough. That's nothing. Yeah. That's enough.
What kind of world y'all live in? Jesus.
3,000, 4,000.
Jesus.
Yeah.
This is where if you like do a lot of Docker builds, doing multi-stage builds is very much in handy because if you're downloading files every time.
And build caches.
Yes.
So there's another thing that we do too as well. So when we build it once, we pull it down and we store it in a local container registry that's on the cluster. So you're not rebuilding every single time and pulling down every single time. You build it one solid image, and then you just build on top of that image.
Which is what you guys do with your Factorio deployment, right?
Yes.
Yes. The initial build when we first were piloting it was downloading Factorio every build phase. So that build I think was about 14 minutes.
But you also have you can also control what's called the pull policy with the build policy, right? So let's say, for example, I want to build, it's done.
It's done.
Yeah.
Is it up?
So what we do now is that was the build. So now what we'll actually go to is the topology. We see the pod. Now if you see this image, this air pull, image pull, give it a second. Sometimes the container builds our rear end gets in front of our face sometimes with Kubernetes. But what happens is that we just wait a second, it pauses for a second, we back off, and then bam, it goes through. But that's just, you'll see that on new builds. We'll get right in front of our own face.
So it's running now?
It is running now. Right there. There it is. So that's just an example of what it can do, right? Now, that's just the build. We're not done yet. We still got more we can showcase here. So after the build is done, it's like, okay, that's cool, dude, but like, what happens when things are broken? Like, do I have to go in and just kick this thing in the face myself? Or like, do I have to so it's like, okay, great, so that works, yes. Next, we did the build stats, so yes. This will kind of walk you through what to look at, all the things that are fun. Now we go on to the next phase, so start 2. Now we get to add health checks. This is where we're like sending probes in, like, you good, bro? You good? You good? And it's like, so now we're basically running through it here. So now you click on the perspective switcher again, we make sure we're the developer, then we go to topology, we look at the pod itself, and then we click on the deployment to view details, right? So we'll click that here, and then we go down and say, look, hey, look, here's the observe. Now what I want to do is, let's see, view the details, side panel, yes, great. Hit next. Now what we'll do is, okay, so view the information resources, yep, that's there. Next, now we're going to add health checks to the app. So to add health checks to the app, we're going to go into, it's right, I always lose sight of this because I never set this up, but it's right here. So we add in health checks. We had 3 types of health checks. Readiness probe, liveliness probe, startup probe. Readiness is, we check to see if the container is ready to handle requests. We just send a GET, we can send a POST, we can name your HTTP header. And at various stages of the actual process. So to give an example, let's say you add a readiness probe. The readiness probe checks to see like, hey, are you ready to start receiving requests now? It says, yes, I'm ready. Right? Now, if we can specify the failure threshold. So let's say if you get 3 fails, you get 3 404s or 3 403s and say, nope, I'm not ready. Now we're gonna fail, we're gonna shut the container down, and we're gonna kick it in the face and then kick it back up, right? So cool. So let's just say the defaults. Now we have a readiness probe, liveliness probe. We check to see, are you running? Like, is everything good to go? Yep, okay. Now you can even come in here and say, hey, look, I want to add a header. Not only do I want to send a get, I want to send a push, but specify I want to send a cookie in. Does that work? Great, cool. So there's all these little automated checks that are super simple to set up. So when we start getting complex with things, that's where things get a little haywire. And then the startup probe. So the startup probe is like, hey, don't start serving requests until we're up, until you've gotten 3 requests back. So now there it is, bam. So yeah, so we're all done. Yes. Now we go to the final stage. Don't you dare get in my way, Murphy. I swear to God. And then we hit start. So now we do a monitor, right? So let's say you want to look at the like, this is kind of limited to the dashboard right now. We don't really have anything for like, was it PagerDuty? Other, we can implement that later on. We just haven't had a need to do it yet, but it can be implemented. So do you see the metrics in the side panel? Let's actually go back to the app. Where was it at? There it is. So you actually go back here and click on the app itself. Like here's the Node.js app. And here you see the metrics. Yep, do you see the metrics? You see the dashboard links. So, huh? Oh.
What are the metrics? I can't see that far.
Oh, sorry. So the metrics here, we can see the memory utilization, the CPU, we can see network in, network out, file system utilization, what all that looks like. We can see everything this thing is doing. So all of this uses Prometheus, by the way, just ProMQL. It's the same stuff that we're using prior.
Is it just the stuff that the host is collecting, or could you
Yeah.
tie in your own telemetry?
So you can tie in your own telemetry. We haven't worked that part out, but it's something we can do as an RFA or feature request. So.
So Ilya is trying to find instructions, right?
Yeah, go to the wiki, and then they called development form.
How do you get to wiki?
If you go to the main page, I'll show you here.
Oh wait, it's actually the temp. You have to be the Tampa Devs.
Ah, okay.
Yeah. Yeah, my bad. Let's go back here. Yeah, so here we can see the CPU memory usage and receive bandwidth. All that is, you can see it right there in the dashboard. And then we can specify like, hey, I think it's a time limit too as well. No, observe. There we go.
We might want to ask them what questions do you
Oh yeah,
guys
sorry.
have?
Do you guys have any questions?
What questions do they have?
Yes.
I remember when you guys stated that you did the fact for the YAML and JSON config, but there's no user interface for it.
Say again?
Say it again.
Can you? Sorry, I didn't hear you well.
Oh, sorry. I remember when you guys stating that for the YAML and JSON config, you guys stated the fact there's no user interface for it. Are you looking for something to upload or no?
I mean,
I think if you're down for it.
Yeah.
we can't.
You
Here's.
well, come talk to us.
I will put it this way. So if you want to, if anybody wants to bootstrap like anything within the cluster, I'm all for it. I will not gatekeep you. I will gladly pull you in. But the thing is that you have to keep in mind that this community, it's all volunteers. So if you bring it in and you do it in a way that can be maintained, yes, we'll bring it in, what have you. But if it's going to be very difficult, time consuming, and it's going to require a cost to maintain it, we may push back on it from that standpoint.
100%.
Yeah, but if we can find a way to automate it where it comes in and it requires very little maintenance, then yeah, we'll bring it right in.
Also, for your contributions, because we'll have certain degrees of visibility, we're more than likely very happy to kind of pop you up on whatever job search scenarios, because the resume stacks are huge these days.
Right. Mine's a
So,
double.
oh, he's really good. Pop, and then that's another plus. Yes.
So, but here's like the metrics one. So this is what we did was that we went over here to the observe side over here, and we click on the observe. We'll see the metrics for the namespace, for the workloads that are running in that namespace. and then we can see like, hey, the last 30 minutes, you can specify the time intervals, what that looks like. We can specify the refresh rate. We can see what CPU, what's being used where, what have you. Like, and it's all color coded right here. You guys can see it here in the legend. And then yeah, and then we go next. And that's it. And those are the, once you go through those three core right here, you should have a pretty good understanding of how to deploy things inside of the cluster. We can actually make these. They're called console quick starts, where like if you guys, the developers, don't, we can't really, I don't really want to make any code, but I do want to like contribute back to something. Like I want to put together a how-to article. Those right there. Like how to deploy this kind of app, or how to deploy that, or how to deploy this. We can write up a whole console quick start. We add that into the GitOps, the GitOps apps repository. Argo CD, which is the, I'll actually show you this. This is a really cool part. So Argo CD is, I love that little orange guy. He's the logo. This is the cool part. So Argo CD is a continuous deployment operator inside of Kubernetes. You have these, you can deploy things by Helm and then a thing called operators, which to do the whole life cycle of the code deployment, but they run on the system cluster level. So typically, what we do for like cluster level resources, if I want to sync changes from a repository somewhere, but I don't want the developer or somebody interacting with the infrastructure side, just interact with the code and make changes there. What Argo does is Argo goes through and uses what's called an app of apps model, where we go out to each different repository where these configs, these Kubernetes resources, all right? So like the YAML files that actually run inside of the namespaces, those live in those repositories. So sealed secrets, OpenShift NFD, MetalOB, GPU operator, console quick starts. And whenever we make a change to one of those console quick starts, Argo CD will notice that change, sync from the repository, and then push it to the namespace inside of the cluster. But this is more so Kubernetes resources, not like what we did prior in the console quick start. We pulled down the Git repository code and deployed it out. So this is for like, if you guys want to get more so on the infrastructure side, then we go down the Argo CD route and what have you. But if you want to get more so on the app development side, you would stay in the namespace area.
Okay, 10 minutes of Q&A left. Any additional questions?
Yes. How do you handle like persistent volumes? Like for example, you do an intentional reboot, the system is the data across. It's persistent the data.
Yeah. So the Ceph storage system. So Ceph is a distributed. If you're familiar with like Unraid and ZFS and like the old distributed like distributed storage systems that were proprietary, or like ZFS is a great example of it. Ceph is the distributed storage cluster that we use throughout all of the nodes. So take all of the storage throughout the entire cluster. That gives us our block, our file system, and then our object storage. So think S3, object storage. That breaks everything up into storage classes from there, and then we present those. We take those storage types from Ceph and present that to Kubernetes as a storage class. So within that storage class, and I'll show you here. So let's say, for example, like Brian was showing in his presentation, like let's say I need storage as a developer because I need to maintain persistence across my app deployments. What you would do is you would go into the storage side right here, and then you would go to a PVC. So the PVC is a persistent volume claim, meaning that you need block storage, or I just need file system storage, right? So great example, you don't use a local file system and put a database on that local file system unless you want your performance to go absolutely down the drain. You want to go with like a block storage that has its own file system with it, right? So you would create what's called a PVC. Let's say you wanted to run a database workload on this, you would run a block storage. And in the block storage, you would just specify like, hey, I need 50 gigs, right? And then you would specify its access mode. So single user, meaning one pod can use it, right? Shared access, meaning we can have multiple pods use that same resource block, right? And then read write once pod, I believe is for the ephemeral pods. We just spin those up, write something to it real quick, and then it's down again. Don't quote me on that, but these are the two that you would use as the main two, which is the RWX and RWO. So those are the two within block storage. And then file system storage, here it's kind of the same thing, but we haven't run across a lot of use cases for it, because block just solves 90% of our problem that we run across. And you generally get better performance on block storage than file system storage, in my experience. Does that answer your question?
Yeah. Are we able to like drive the usage of the persistent volume?
Yeah. So once you provision it and put it into the project, you'll see that in your observe dashboard, as far as like file system utilization on the pod.
Are we able to switch the size? Let's say that we don't need like 50 gigabytes, like, and we are able to see the usage, the real usage. Can we change the storage?
Like shrink it?
Yeah.
Typically no, because you can grow storage, but when you shrink it, the problem is that when you shrink storage, it's already been allocated, or how the storage gets written out, it's almost impossible to not shrink storage without causing data loss.
Is it possible to make a copy and create the...
You can do that, yeah. So you would like so you take a pod, and let's say you want to copy from one pod to the other pod, or let's say I want to have the volume over here at 20 gig, volume over here at 20 gig, I want to copy from here to here, and then destroy that. That you can do.
Okay, got it.
Anything else?
It supports SQL, right?
Sorry?
It supports SQL.
Yes.
And are we able to see the tables and everything visually on the UI?
So you would, like Brian was saying, what you would do is that you would spin up a database through a stateful set, and then from that stateful set you would apply the block storage, mount that to the pod, and then forward your local port, OC port forward, your local port 3306, and then that would create an HTTP tunnel from your local host to the cluster. And then you would connect your database viewer to your local host, which then forwards right up to the cluster.
So you deploy your app for the first time into a Docker container from your GitHub repo.
Yeah.
Does it keep in sync with future commits that you do the code?
So you need to add some sort of logic to that. And the logic is generally a web config. A webhook. The webhook pushes to the GitHub, like from GitHub or GitLab to the cluster via its API, which you'll see within its secret management side. I believe within secrets, yeah, so right here in the secrets, you'll have like the Docker config, what have you, which will give you the actual API link, which then you can just slap into GitHub and then it pushes right to the cluster. The other beautiful part is that we automate SSL as well. Cert Manager automates that whole process. So there's no messing around with like, here's your CSR, here's your key, what have you. If you stay on the Tampa.dev side, you'll never have to renew a cert. But if you want to pull in your own domain, then we have to set up some logic in there. We have to set up with Cert Manager. We've set up what's called a local issuer, where you would maintain your secrets. And then that would connect to, let's say, Cloudflare's API, which would then do a DNS challenge or just do like an HTTP challenge to make sure that you own that domain. And then we all just use Acme. And then Acme does the Acme challenge, and we renew the certificate, and Bob's your uncle, you're done. So, any other questions, comments, concerns? Yep.
Do you have any ideas what kind of projects you'd like to, what's your vision? Do you have a dream project?
I mean, honestly, the coolest project would just be standing up a whole Git, like not a Git, a whole like user forum, like our own little Stack Overflow, where we're all just kind of helping each other learn, whatever.
Just throw PHPBB up there.
The whole point of this project is not to be. I'm not the smartest guy in the room. Like when it comes to the web app side, dude, I'm a dummy. Like when you guys start talking about front end, back end, Java, I'm like, no, I'm there. But when it comes to the data center side and scaling networks out, what have you, that's where I live. the data center in which this whole cluster lives in, I built that whole network. So that's a whole BGP data center from core to rack.
So if I need some compute capacity to, I get a password and I want to decipher it, I can use your sources.
Yeah, kinda.
There's some
It's-
GPUs in there.
There is, but I'll be dead honest with you, it's not gonna be fast. I mean, it take 10 years. Well, you wanna wait? So we do put a quota limit on everyone. And the reason for it is because, we want people to be able to use it, right?
This is fantastic because I once paid $3 a month for Amazon because I closed my EC2 instance, but I forgot to destroy EMD
Yeah.
block.
Yeah.
I paid $3 for 12 months,
Yes.
until I figured out how to pay.
Right.
You're good. I got a bill for $100 the other day out on the bill.
Yeah, we'll never do that to you. There's no credit cards required for Tampa
Although,
Devs.
if you guys are bootstrapping a startup and you guys do succeed, at least have some degree of revenue, please consider throwing back into the cloud.
We don't require it, but
Well,
we do
if you're really
appreciate
nice,
it.
then give some, take some, guys. Give some, take some.
But I mean, ultimately, the key concept here is just that, like, hey, Tampa is a target-rich environment.
Who is a startup founder here? Anybody? Y'all? We got 4? Okay. If you guys need funding, you should talk.
But Tampa is a target-rich environment for this because there's like so much automation and containerization workloads that we can employ to help simplify a lot of stuff. I mean, I've seen a lot of Windows environments out there, and I'm sure you guys have all run into, like, why are we doing it this way? This is a great way to show your employers why you guys should adopt containerization.
It's not done, no, but I have a job board application that I put together that in the future I could make a version of that and deploy it for you guys. I have no economic interest in it, it's just that
Yeah.
I have it, so.
Right, yeah. So like, another thing too, just to kind of show you like blogs. Here's mine. And I gotta make this plug here, man, I have to. Because it's being recorded right now and it would be, here's my blog. I run Arch Linux, by the way, just letting everybody know. So here's my old blog. It's just a Hugo web server that I have here. It has a terminal in place. So, these are all the articles that I've written while I worked at Red Hat and all my skill sets and applications, what have you. Also, for the record, I know you guys saw the OC command. The OC command stands for OpenShift Client. The enterprise version of this is OpenShift, but this is not OpenShift. There's a lot of references to OpenShift in this cluster, but this is not OpenShift by any means. This is the
Actually, you might want to actually give a high-level overview of how.
So at the very base layer, we have containers. Containers then go up into what's called Kubernetes. Kubernetes the problem is that when you start going beyond one cluster, now you have to start wrangling cats around. It's like, okay, well, how do we manage all this? So we have 2 ways to do it. We have a bunch of different ways, but from the perspective of the enterprise side, you have 2 main providers. You have SUSE, which uses a Kubernetes distribution called Rancher, and then you have Red Hat. They have a Kubernetes distribution called OpenShift, which is it's using Wolfram to do math, more or less. It's a platform to manage Kubernetes clusters.
If you were to tell them like the market distribution between the two.
Oh yeah. So containerized workloads are huge, especially in the enterprise environment. SUSE environments, they're going to be more so in European customers. You're going to see a lot of SUSE people over there. Over on the United States side, it's more so a lot of Red Hat.
Also, just so that they know why there would be more SUSE in Europe, why?
I don't 100% know why, but SUSE has always been dominant in Europe and Canonical as well.
So Canonical was started by the South
Mark
African.
Shuttleworth.
Yeah. Right.
Okay.
And so not American.
Yeah.
And then
South
SUSE-
African.
Yeah, and then SUSE, I think was German in its origin.
That's right.
Yeah.
So that's why SUSE is more European based,
Yeah.
like more of a European market. Ryan might have a more perspective on this, right?
No.
He's like, no, Ron.
I'm recently to the cloud.
Okay. So I mean, and then also too as well, you can run virtual machines inside of containers with a project called KubeVirt, which is what we're trying to do right now. It allows you to run virtual machines in a container Kubernetes environment.
So we should probably wrap up so that one, a
Yep.
little bit of networking time for
Sure.
attendees. Two, we should help the host clean up a little bit so that we're not.
I agree. Yep. So
Thank you all
guys.
for coming.
Yeah, thank you.